Okay, we're going to talk about 2-4. Okay, I'm going to go over the essentials. So, first of all, we're going to divide polynomials, and just like we do with numbers. So, there's some vocab that you need to know. All right, in the book, these are in the book. Those of you that read it last night. Quotient, remainder, divisor. Those are definitely words that you're going to want to know. So basically, we know that a function is, we can make up a function. This is going to be important right here. Function is really a divisor times a quotient plus a remainder. And what that means is like this. Say I divide 3 into 10. All right, 3 goes into 10, 9, whoops, not 9 times, 3 times. 3 times 3 is 9. All right, when I subtract, I get a remainder of 1. So this is really 3 and the remainder is plus 1 over the divisor 3. So the answer is really 3 1/3. Correct? So the original, this is the divisor. This is the quotient. This is the remainder. We're going to do this with polynomials as well. So we can take the divisor, multiply by the quotient, in which case we'd have 3 times 3 1/3, and that will give us the original number back 10, which we'd call then our function, I guess. So this is our f of x. All right, so there's an example with numbers. Yeah, you can write it in a better form like this. Divisor times quotient plus the remainder gives you the original number or the original function when we do polynomials. Yeah. So we'll practice this more, but some vocab, it gets a little confusing at first, but as you do, especially when you go from numbers to polynomials, but hopefully it'll make more sense. Here's an example. Okay? I want to do a long division with this polynomial. So, to do long division, you do make sure everything's in standard form. I'm going to divide this polynomial into this one, 2x to the 4th plus x to the 3rd. Now I have to say plus 0x squared plus 0x plus negative 3. Because this needs to be in standard form when I do long division. That's going to be important. All right? So now what you do is you say, okay, what do I put on the top to be able to multiply x squared to get 2x to the 4th? First of all, if I divide a quadratic into a 4th degree polynomial, what's my quotient answer going to be up here, do you think? It's going to be a 2nd degree quadratic. Yep. Good call. So I'm going to put up here 2x squared. Because when I multiply 2x squared times x squared, I get 2x to the 4th. I'm going to follow through. So 2x squared times x is 2x to the 3rd. 2x squared times 1 is 2x squared. And I'm going to subtract. All right. When I subtract, this is going to cancel. So I'm going to now subtract this. So this turns into 0. X cubed minus 2x cubed gives me negative 1x cubed. And 0x minus 2x gives me negative 2x squared. Now I'm going to drop down the next term, which is plus 0x. Now what can I put up here to multiply by x to get the next line? All right, so I'm going to multiply by x, negative x, so that I get negative x cubed when I follow through. Negative x times x gives me negative x squared, and negative x times 1 gives me negative x, and now I'm going to subtract again. These cancel. This is negative x squared. When I do negative 2x squared minus the double negatives go positive. And then I have positive x. I'm going to drop down the next term, which is negative 3. Okay? Now what would I put up here to multiply by x, get negative x squared? That would be negative 1. So I have negative 1 times x squared, which is negative x squared, negative x, and negative 1. Now I'm going to subtract again. I guess I could have wrote that in a different color again if I was going to stay consistent, but whatever. So these cancel. This turns into 2x, x minus a negative x, and then negative 3 minus negative 1 turns into negative 2. So this is my remainder right here.
Why isn't that positive?
So this is my remainder. My answer then is the quotient plus the remainder divided by the divisor, and the remainder in this case is 2x minus 2 over the original divisor, which is x squared plus x plus 1. Seems like a horrible answer, but you know, it didn't go in evenly, basically. This polynomial didn't go in the other one evenly. So basically what that means is this original polynomial that we divided in was not a factor of this polynomial. We're going to do a lot of them where this will be a factor, in which case you'll get no remainder. And that's going to be another way that we factor polynomials. So basically what that means for us is if we know 1, 0 of any polynomial, I don't care what size it is, we can then divide that factor in and get the rest of it. Okay? And we'll do that soon. So this is the original function. This is the quotient, q of x we'll call it. This is the remainder. Here I'll call it r of x. This is the divisor. I'll call that d of x. All right, that's long division. We'll do synthetic division in a second, which will be easier. All right. First of all, the remainder theorem is going to be something you want to know. The remainder theorem says if a polynomial is divided by some factor, then the remainder is always equal to that number right there plugged into the function. So if we're going to divide x minus 3 into some polynomial, all right, if I want to find the remainder, all I have to do is take the k value. This is really x minus 3, so k is equal to 3 here. I have to plug into the original function, so I plug it into the original function right here. So it's going to be 3 squared is 9 plus 3 plus 3 gives me 18, or I'm sorry, 15. So the remainder is 15. And that's a lot quicker than actually doing the long division. All right, if we could do the long division we wanted, we'd put x up here, so that x times x was x squared, x times negative 3 is negative 3x. And then subtract, in which case these cancel and you have 4x here. Then drop down to 3. And then say, what would I put up here? Then I'd put a 4 up here. 4 times x gives me 4x, and 4 times negative 3 is negative 3. And then subtract. And you get 6. 3 minus negative 3 gives 6. So the remainder is 6, not 15. Did I do something wrong? 3 squared is 9.
You didn't do the 4 times 3.
Oh, I'm sorry. 4 times negative 3 is negative 12. Okay. Now we get the remainder of 15, which is the same remainder. Obviously, this takes longer than doing the remainder theorem. The remainder theorem is very simple. If you're dividing into it, just find k. When we divide into it, we're always going to put in this form x minus k. And so if we know this number, we can then just put it into the original function, and that is the remainder. Okay? So here's an example of that. Another example. If I'm going to divide x plus 3 into this function, then really it's really x minus k, right? So what's my k value here? K equals negative 3, right? Because the double negatives will cancel to go positive. So if k equals negative 3, what's the easiest way to find the remainder? Just plug it in. All right, so f of negative 3 is what I want to find. That is the remainder. Remainder equals f of negative 3, which in this case, negative 3 squared is 9. That's 18 plus 3 plus 12. Well, double negatives. So that'd be 33. So that's the easiest way to find the remainder with the remainder theorem. Something you want to know. Save you some time. All right. Factor theorem, a lot of stuff is something you already know, really. A polynomial, if it has a factor x minus, it has a factor x minus k, if and only if, you know, if you plug in that k value, you get 0 for the function. And you know that, right? Because when it's in factored form, if you have x minus 3 times x plus 2 or something, then you know that if you stick in 3, then you're going to get a 0. And so this is a factor, and you know that if you plug it in, you're going to get a 0. That's something you already know. Okay. Fundamental connections is something you also know, and that is, you know, if x equals k as a solution or root to the equation, k is a 0 of the function. K is the x-intercept of the graph, and x minus k is a factor. All things you know. All right. Synthetic division is something that I think you learned also in Algebra 2, but you might need to brush up on it. How we do synthetic division, it's a lot easier than long division. I'd recommend knowing this one for sure. Save you time. What you do is you put 1 here, so you put k here. This is x minus k. Again, so k is 1. So we always put k right here, which in this case is 1. And then you put the coefficients here, 3, -2, 1, -5. Make sure it's in standard form. It is. The exponents are going down by 1 each time. All right. Now you drop down the first term here and you multiply. Put that here. You add again. Or I'm sorry, you add now. Gives you 1. Now you multiply. Gives you 1. You add. This gives you 2. Then you multiply. You add. And this is your remainder.